Unit 4, Lesson 1, Polynomial Functions. So in this unit, we'll use long division and synthetic division. Remember I told you we're going to focus on synthetic first. I'll come back to long division second. By binomial expression, and use these process to means to factor polynomial expressions which are bigger than you're used to. So back in Math 20, you just factored stuff of degree 2 or had even degrees, which you could just factor normal. Now we have stuff that's higher than that. So like cubes, fifths, sevenths, stuff like that. We're going to try to pull out factors. Okay, so we're going to look at that. Polynomial function, what is that? That's simply a function that's written in the form of a(n) to xn, a(n minus 1 to xn minus 1. All those mean is essentially the exponents are like descending. So you have something cubed, squared to the 1. It's just the form of a function. Okay, so it's kind of the labeling of it. I know it doesn't really help you in terms of visualization. This probably does down here. Example 1, that's a polynomial. X to the 4th plus 7x cubed minus 8x squared plus 5. Okay, but what we need to know today for the lesson 1 is how to label these. And so up here, the values of a1, a2, and an are called coefficients. So the coefficients of this polynomial function is 1, 7, negative 8, and 5. Actually, do we call 5? Yeah, 5 is called a constant, I guess. So it's not really a coefficient because it's not multiplying anything. So I take that one back. Okay. The term independent of x, which is a0, is the constant term, so like we just talked about. The value of n is the degree of the polynomial. So the degree of the polynomial is the highest, so that would be 4 for this one. Okay. We'll talk about double variables stuff. Math 9 you always used to forget, I remember. But this one here. So the degree of this polynomial, the first one is simply 4. That's the highest exponent. The leading coefficient is what? That's always the most common guess, but the leading coefficient only comes from the highest degree, so it's 1. Okay, your leading coefficient is the number in front of the highest degree. Okay, the constant term is the 5. Okay, questions or concerns there? Okay, so then recognizing a polynomial function. Expressions containing roots, variables, negative or fractional powers of a variable, or any coefficient which is non-real are not polynomials. So read that again. Expressions containing roots of variables, negative or fractional powers of a variable, or any coefficient which is non-real are not polynomial functions. Okay, so we got to keep that stuff in mind here. So we're going to talk about those right now. So then coming down to example 2, we'll leave this at the top so we can refer to it. Yeah, because we don't need that bottom part there. Okay, perfect. All right, so state whether or not the polynomial function, they are polynomial functions. Okay, if they are not polynomial functions, explain why not. So A. Okay, why is A no? Fractional exponent, good. So this right here, no, a fractional exponent. This does negative 5 is okay. Is that what you mean? Yeah. It's negative exponents, I believe. Okay, B. The negative exponent, right? Okay, so no negative exponent. Okay. So the actual definition says the exponent's not a whole number. Remember, what's your whole number in terms of your number system? Whole numbers are everything 0 and bigger, right? 0, 1, 2, 3. So your exponent has to be positive, what whole number means. But 0 does count, and technically constants are the exponent of 0. Do you guys understand that? Because if I put x to the 0 here, x to the 0 is just 1. And so that makes it the constant, just letting you know. Okay? All right. The C. Psyched you out the root 17. Root 17 is still a value. Your coefficient's okay. When you're looking up here, expressions containing roots or variable, okay? So we have roots or variables. We don't have roots of variables, okay? We don't have negative or fractional powers, okay? And we don't have any non-real numbers. Like if that was root negative 17, then we'd have a problem, right? Okay, but it's not. This one's okay. So C is good. Sorry. Okay, how about D? Yep. We got yep, nope. No. How about we just have a group of maybes? Okay, it's a no. Yep, because I think I heard it back there. The first term, that square root makes it 5x to the 3 halves. So you have a fractional exponent. Okay. If there is a 9, that'd be 9 halves. This is a 9. If it, you know, it was a good question. I think if you meant like, because this right here is actually this. That's what it is. If that was a 4, maybe it would work, because then it's now you don't have a fractional exponent. 4 over 2 is 2, right? So that one might actually work. Okay. So we'll look at that as we get going here. Okay, and that's what we'll talk about this example here. So you guys are right. Be right with what the book's going to do to you here. Okay, so this one's no. 3 halves as an exponent. Okay, good. Okay, so if you weren't really involved, or maybe I'm not hearing Aiden right, but the question that I was getting or hearing was, essentially, if you square root or you take half of something you can actually half, is it okay? Yes. So like right here, I can take half of 2. It's 1. Right? So now I'm okay, because I have a whole number exponent. Is everybody hearing me there? So this was great. 5x cubed, no problem. Right here is the first thing you're looking at the problem. Like these 3, no, we don't care about. They're all good. This one's the problem. So it's 3 to the 1 half and x2 over 2. Well, 2 over 2 is 1, so that means it's 3 to the 1 half x, which is fine. Right, we don't care. Right, we don't know, because that fraction on that number, 3 to the 1 half is root 3. Root 3 is a value. That's okay. Okay. Ask questions. This is day 1. This is your foundation for the unit. So if there's anything that's just going over your head, stop now. Don't wait for later. Okay. All right. F. How about this? For F, right, F, the variables are cool. All the variables are fine. The one problem is we have a non-real in here. We have root -3, which is a non-real number, so that makes it no. Yep, fake. Okay, cool. All right, let's keep going. We just have kind of some examples for this section. We'll get synthetic division today. All right, degree, leading coefficient, and constant term now. Okay, I actually never really heard it described this way, but I kind of like it. Okay, sometimes they can be mixed, matched, or mixed around. A lot of your tests do that, where you think things are supposed to be nice and easy and in order for you. Well, sometimes they're not in order, so they call that disguised form. So a lot of people, when they see this right away, they're going to say, oh, 34 is my leading coefficient. But 34 is not your leading coefficient, because cube is your highest degree. So you've got to make sure that when you're disguised form, it's probably just smart to go ahead and reorder it, or just know it's not in the correct form. Okay, so with that, on A, the degree is what? 3, good. So that makes leading coefficient -25. Don't forget the negative, that does apply. And what's the constant? -39. Okay, part B. So this one, it's factored down. Okay, so we do want to see what is it. We need to get in polynomial form. So that's going to be 10x squared. We know 10x squared is going to be our what? Yeah, that's our degree and our leading coefficient, right? Because that's going to be the highest degree. So 2 and 10. And then we can get our constant pretty easy by doing what? Yeah, -7. So you don't have to FOIL the whole thing out. Okay, and you're going to get used to that stuff with polynomials. Remember that problem we did earlier where we got the y-intercept by timesing the constants? That diploma question? We had the 3 brackets, and we times the constant gets 12, but it told us it moved down 8. So we said, oh, if it moved down 8, then it was 4. Anyways, if you don't remember that kind of strategy is how we can understand where our constant's coming from. Okay, cool. All right, example 4. In the following polynomial functions, determine the degree, leading coefficient, constant term without expanding. Without expanding. So they want you to go ahead and do what I just talked about, understanding what's going to come out of this. Okay, so go ahead and I'll pause the video. I want you to try these 2 with your table partner. Okay, Leo, you can just turn around with Ty or whichever works. Okay, so good job, guys. Like that's when I ask you guys to do a question like that, that's like the perfect environment that I like. Like everybody was asking or saying things to each other about why it's this or why it's that, and not fully knowing, and that's the learning process. Like when you're having conversation what you think it should be, that's how you discover what it actually should be, even if you're wrong. Okay, so just want to give you like props there. That was really good in terms of you guys discussing that. So a couple things to look at here. Just know this. The big thing on these two, somebody said, hey, they look exactly the same. They do, but that's an addition. That's multiplication. So you're going to have different stuff, and that's the point. But the degree. So we don't want you to expand because, for one, as I told you on that question diploma that I put up, the one that had the 3 there, some of you guys expanded that thing and wasted 10, 12 minutes. You don't have that time on the diploma to do that. Okay? So they put stuff like on here where you're supposed to do them essentially faster because they track how much time they think it should take, right? Okay, you have a lot. True, you have a lot, but I would say you have 6 hours, but you don't have 6 hours. Like don't wear yourself out. Exactly. Okay, so here we go. This one here, we know the output of this is going to be 9x squared in front, right? This is going to be 9x squared in front. Okay, and we know the output here. This is not being squared. I think it's just 5x squared. Okay, so then we know that when I multiply these, I will get a degree of 4. Okay, now the leading coefficient is going to be a little bit tricky. It's going to be the 9 times a 5, but you also have this 2 here. 9 times 5 is 45, times 2 is 90. Okay, we doing okay? Okay. Now, the negative 1 squared is 1, times 2 is 2, times 1 is 2. So you're going to have 2 for your constant here. I'm just looking at the constants. Like I don't care if stuff that's happened in the middle. I don't have to combine like terms. This 2 is not being squared. We can't distribute it into a square. Right? You have to do this first and then hit with a 2. So when I do this first, the negative 1 squared is 1, times by 2 is 2, times 1 is 2. That's going to be your constants you're going to be multiplying. So like, if you do it out, I can do this one out really quickly, so I'll show you, even though I told you not to expand, if you want to see it. 9x squared minus 6x plus 1, you times it by 2, right? So then you have the 2 there. That 2 is going to hit that 1. That's all we care about for the constants. Okay? Second one. Okay, so the thing's going to change is we're not going to multiply these. So now your degree is not going to get to 4. It's going to stay at 2. Because you have a 9x squared or an 18x squared, and you have a 5x squared. So we know this right here. We said the first one's going to kick out a 9x squared in the front, and we times that by 2. So that's 18. And then we're going to add 5 to it. Those are going to be my leading coefficients. So 23 will be your leading coefficient. A lot of mental math here a little bit.
When you add, your exponents stay the same?
Absolutely, yeah. They're like terms. Yeah. Okay, good question. Just a review. When you add, your exponents stay the same? Yep. Okay, they stay the same. Okay, constant. Okay, the constant on this one would be what? Yeah, because the negative 1 squared is 1 times 2 is 2 plus the 1, so it's 3. Okay, good? All right, so as we do this, we got to keep just identifying those things, like making our work less. Okay, we don't keep going. Okay, explain why the polynomial function p of x of 7 has a degree of 0. So why does it have a degree of 0? So we're just talking about just a function. It's silly. It's just a 7. No, there's no x's, there's no y's. Why does it have a degree of 0? Yeah, we talked about that. A constant is something to the 0 power, essentially. So yes, degree is 0. No variable. Okay. Explain why this type of function is called a constant function. Like, what's the word constant mean? Yeah, always doesn't change. So that line is always 7, right? There's no change or up or down or slope. So it's just, constant. The word you guys said was always, doesn't change. From 7. Okay. Always doesn't change. Just like saying, like words that describe a constant. You can use your own words if you want. It's an always though. Just like these are two terms that describe constant.
Didn't we say before that something with a degree of 0 is equal to 1?
Yes, but this is equal to 1 times the 7.
Oh.
Because the 0 power is 1, right? That's what we meant. Okay. We good? Okay.
Can you go back to the class example 4 on B?
Sure. Number 4, B, how we got this constant. Sure, let's do that one more time. Okay, so 4 on B, explain how we got the constant. The constant this one, when you do this right here without expanding, it'd be a -1 times a -1, so that's a 1. Right? And then we're going to times that by 2. And then over, see that plus sign? That's just a 1. And so that's going to get you 3. Yeah. So it's addition, not multiplication. All right, here we go. Let's go to the next page. Okay, so then we got classifying polynomial functions. We can classify them by number of terms. So remember, we got one term's monomial. That's kind of the weird one. Binomial makes sense for 2. Trinomial makes sense for 3. 4 or more is just called polynomial. They don't really keep describing them after that. So simply, guys, 1 is monomial, 2 binomial, 3 tri. Anything after tri is poly. Okay, by degree, polynomial functions can also be classified according to degree, such as constant, so degree of 0, that's what we just talked about. Linear, degree of 1. Quadratic, degree of 2. Cubic, degree of 3. Quartic, degree of 4, etc. I'd say you need to know these first 4 really well. Yeah, these ones you need to know really well. Okay? So they use, if they say you have a quadratic with the zeros 2 and 3, you need to know what a quadratic is. If you don't know what a quadratic is, you're not going to know what they're asking. Okay? All right, so here's the just labeling. Degree of this one is 0. This one would be a constant. This one is a degree of 1. This is the linear. Degree of 2, quadratic. Degree of 3, cubic. Degree of 4, quartic. And I guess quartic too. Quartic doesn't come up as often as all. Yeah, I think they do that mostly because it's like the symmetry of it, but because I mean linear, it doesn't really have what makes linear 1.
A line.
2.
A line is 1.
Just 1. Okay. Good. All right. This piece here, research names of polynomials for degrees 5 through 10, so we can go through that later actually. Okay, so polynomial functions can also be classified according to their coefficients. For example, 3x to the 4th minus 5x squared plus x plus 7 is an integral polynomial function because it has plus or minus. Okay, so integral, so that means if they're all pluses, you don't really need to say integral because integral allows you to have negative coefficients in terms of its labeling. This one's a rational one because you have a rational coefficient. Okay, and this one's a real because root 3 is not irrational. It's an irrational number, right? So it's kind of knowing your number system. So if you forgot that stuff, here's your quick run through one more time. Okay, I'll do it this real quick. This is Math 9. You have your natural numbers. Whoops. You have natural numbers, which is which numbers? Not 0. Natural is 1, 2, 3, 4, all positive whole numbers. Whole numbers is the same thing, but 0 included. So that's where whole numbers is. Okay, what's after that? Integers. And that is plus or minus, okay, your 3, 2, 1s, whole numbers. Okay, and after that? Rational. That's your fractions. Okay?
Do you guys not have real numbers?
This whole thing is the real number system. Yeah. So like the whole this is the real number system chart. Okay? So let me finish, I'll show you. Over here, that's not part of the bubble is the irrational. That's pi. That's e for us, natural log e. That's root 3s, stuff like that, are irrationals. The definition of irrational, and we said it like 100 times in Math 9, non-repeating, non-terminating decimals. So you put in your calculator, you don't see a pattern. So like pi goes on forever, we know that, and it doesn't repeat. Okay? So like 1/3 is not over here, even though 1/3 repeats, right? That's why 1/3 is over here. Now, to what Bob was saying, all of these are part of the real number system. We're getting way off track here, but that's okay. You need to know this. Okay? And so these guys are outside of the real number system because that's not a real number. That's why that can't be part of our polynomial. Okay? So, again, to what they said, integral. Why is this integral? Because it's plus or minus coefficients. Why is this one rational? Because it's a fractional coefficient. Why is this real? Because it's a root 3, which is an irrational coefficient. Okay, so that's where those labelings come from. Any clarifications on that? You guys want to make another poster of real numbers? Okay. In each case, write a polynomial satisfying the following conditions. So you go ahead and do this. Okay? So a trinomial that's quartic and integral. A binomial that's linear and real. A monomial that's quadratic and rational. I'll call up 3 people to put theirs up here and we'll make sure it's good. All right, good. So the 3 we got here, we got 4x4, 4x4, 2x squared. What's the last part, Donovan? Minus 2. Binomial, linear, and real, we got root 7x plus 6. And then the monomial, quadratic, rational. Okay, so let's look at these and make sure. So trinomial, 1, 2, 3, good. Quartic, highest degrees of 4, good. Integral, it has a minus for one of the terms, so that makes it integral, good. That one's perfect. Binomial, linear, and real. So I like that you put root 7, so that's good. Root 7 is a real number, so that's good. It's with an x to the 1, which is good, and you have 2 terms, which is good. So B is good. And the last one, a monomial, you got a single term. It's quadratic, so it's squared. Rational, so the coefficient is 2/3. Perfect. All right, let's finish this up, and then we'll get to the synthetic here. All right, so if p of x is negative 3x squared plus ax plus 8, and p of 1 equals negative 9, then find the value of a. Okay, so what we're going to do is we're essentially just going to solve for a. Now, this sounds a lot harder than it is. All you need to do is put 1 for x and solve for a, because you're going to have one variable. That's all you need to do. Okay, so you're going to go negative 3, because 1 squared is 1, plus a plus 8. Right? And we know p of 1 equals negative 9, so this equals negative 9. And that's it. Now we just solve. 5. A is negative 14. What's that? My 3? Negative 3 plus 8 is 5. Minus 5 both sides, negative 14. Okay, this next one it's a little bit harder because we're going to have to do a little bit of our Math 10 stuff of system of equations. So we'll get to that. And we'll finish there with this one. Okay, so determine the values of a and b. So we have 2 variables we're finding. So when that happens, you're usually going to have to use some type of system or usually elimination or substitution to solve. So let's see here. If p of 2 is negative 18, so that means the first equation I'm going to have is negative 2 times 2 squared plus 2x plus b. Not 2x, sorry. I put 2a, thank you. (2a). There we go. Okay, and the whole thing equals negative 18. So let's get that simplified, and then we'll do the second one. So that simplified is negative 8. So we want 2a plus b. If it's you said 4, right? Times negative 2 is negative 8. I'm going to add the 8 over. So I get negative 10. So this is my first equation. You like to kind of have the variables on one side and the constant on the other side when you're doing systems. The second piece, p of negative 3 is negative 13. So then we have negative 2 times negative 3 squared plus a times negative 3 plus b equals negative 13. Okay, so negative 3 squared is 9. So this piece is negative 18. So I'm going to add 18 over. So equation 2 is negative 3a plus b equals 5. Okay? So now, when you're doing systems, you always want to look and see, do I have a consistent term? And I do. It's b. So right away when that happens for me, I think elimination. Because I know if I minus these equations, the b's will go away, and that's the point. Okay? So what I'm saying is, as soon as I see that I have two things that are exactly the same, I'm thinking elimination. I'm going to minus. Okay? So 2 minus a negative 3, that is minus a minus, so that's 5a. b minus b eliminates, that's why it's called elimination. Negative 10 minus 5 is negative 15, so a is negative 3. Okay. Now we put negative 3 in for a, and we'll get b to either equation. So we'll put it into 1 here. So 2 times negative 3 plus b equals negative 10. Negative 2, that's negative 6. Add 6, add 6. b is negative 4. Okay, you can put in either equation too. It doesn't matter which one. So a is negative 3, b is negative 4. Okay, any questions on that process? A little bit of Math 10 review. Math 20, we don't do too much systems. It comes with a little bit on some challenging problems, but it's been a while since you've seen elimination. So, okay, we'll stop there.